In today's lecture, we will see multiplication of two DFTs, a circular convolution. Suppose we have two finite duration sequences of length n, x1n and x2n. If we take n point DFT of these two sequences, we can write the DFT of x1n as x1k equal to n equal to 0 to n minus 1 x1n e raised to minus j2 pi nk upon n, where k is equal to 0 to n minus 1. Similarly, we can write the DFT of other sequence x2n as x2k is equal to summation n equal to 0 to n minus 1 x2n e raised to minus j 2 pi nk upon n, k equal to 0 to n minus 1. If we multiply these two DFTs, the result is also a DFT. Let us assume the multiplication of these two DFTs is x3k, where x3k we can now write as x1k into x2k. So I can now say that this x3k is a DFT of a n point sequence x3n. Now let us try to find out the relation between x3n and x1n and x2n. So now if we take n point IDFT of x3k, so by taking IDFT of x3k, we can write x3m is equal to 1 upon n summation k equal to 0 to n minus 1 x3k e raised to j 2 pi mk upon n, where m is equal to 0 to n minus 1. So now, as this x3k is equal to x1k into x2k, we can write this as 1 by n k equal to 0 to n minus 1 x1k into x2k into e raised to j 2 pi mk upon n. Now, let us substitute x1k and x2k from these two equations. Hence, this x3m can be written as 1 by n summation k equal to 0 to n minus 1. So, I will write now x1k, so which is equal to n equal to 0 to n minus 1 x1n e raised to minus j 2 pi nk upon n. Now by writing this x2k, I will just replace the variable of summation from n to l. Hence, this x2k can be written as l equal to 0 to n minus 1 x2l e raised to minus j 2 pi lk upon n. And then you have e raised to j 2 pi mk upon n. Okay, so now by interchanging the order of summation, we can write this as 1 by n equal to 1 by n. I will first write this. So n equal to 0 to n minus 1 x1n. Then I will write this part. So L equal to 0 to n minus 1 x to L. Then we take the summation k equal to 0 to n minus 1 e raised to minus j 2 pi nk upon n into e raised to minus j 2 pi lk upon n into e raised to plus j 2 pi mk upon n. And now this can be written as 1 by n summation n equal to 0 to n minus 1 x1 n summation L equal to 0 to n minus 1 x2 L summation k equal to 0 to n minus 1 e raised to j 2 pi m minus n minus L k upon n. So now let us consider the summation inside this bracket. Let a equal to e raised to j 2 pi m minus n minus L upon n. In that case, this particular summation can be written as summation k equal to 0 to n minus 1 a raised to k. And as we know, this particular summation is equal to n if a is equal to 1 and it is equal to 1 minus a raised to n upon 1 minus a if a is not equal to 1. So now for a to be 1, m minus n minus L must be multiple of n. If m minus n minus L is multiple of n gets cancelled and this term will be e raised to j 2 pi into some integer, and we know that e raised to j 2 pi into an integer or integer multiple of 2 pi is equal to 1. So hence this a will be equal to 1 if m minus n minus L is multiple of n, and if for any other value of m minus n minus L, this a raised to n will be equal to e raised to j 2 pi m minus n minus L, where m minus n minus L is an integer, and hence whenever m minus n minus L is integer multiple of n, the value of this a is equal to 1, and there this summation is equal to n, and whenever m minus n minus L is not multiple of n, this a raised to n equal to 1, and therefore from this 1 minus a raised to n, which is 1 minus 1, it is equal to 0, and therefore that summation comes out to be 0. It means this particular summation for L equal to m minus n plus pn, that is equal to m minus n mod n, the value of a will be 1, and for any other value of L, a raised to n is equal to 1. So therefore this particular summation is equal to n wherever the value of L is equal to m minus n mod n, and for others this summation comes out to be 0. Therefore now we can write x3m is equal to 1 upon n summation n equal to 0 to n minus 1 x1n. Now from L equal to 0 to n minus 1, for the value of L which satisfies this condition, this particular summation is equal to n, and hence I can write this as x2 of m minus n mod n multiplied by n. So this n is actually the value of the summation. And for other values of L, as this particular summation comes out to be 0, so this exists only for one value of L, where L is equal to m minus n mod n. And here this n gets cancelled, and we can write this x3m is equal to summation n equal to 0 to n minus 1 x1n x2 of m minus n mod n. So this particular equation is the circular convolution. So the multiplication of two DFTs is equivalent to circular convolution of the corresponding sequences in time domain. So I hope you understood the derivation of the circular convolution. Thank you.